Have you ever, thought about whether the things you do today could somehow ripple back in time, and maybe even shape stuff that already happened? We're going deep on that today, backward causation.
It's a real head scratcher. Philosophers, even physicists, been wrestling with this one for ages. Makes you wonder about cause and effect, right? Maybe even time itself, how it all works.
Yeah, we're digging into some heavy stuff for this deep dive. There's this whole entry in the Stanford Encyclopedia of Philosophy, backward causation. It's a lot, but we'll unpack it, make it make sense. And then there's this real-world experiment, the delayed choice quantum erasure. Super out there. You can check it out on Wikipedia.
What's so wild is that we're going from these big philosophical ideas to a real experiment. We're bridging the gap between thought stuff and actual quantum mechanics.
So back to the beginning. What are we even talking about when we say backward causation?
Okay, so imagine this. The future, right? It can actually be the cause of something in the past. It's how should I put it? Picture a movie and the climax. That's what sets the stage for how the whole thing starts. Weird, right?
So hold on. Isn't that just time travel then? Going back and messing with the past?
Not really. Time travel usually means these loops going back to meet your past self. But backward causation, it's different. Think of it like a ripple, but it's flowing backwards through time.
Hmm.
Subtle, influencing things without needing a DeLorean.
So not changing the past exactly, but influencing how things went down.
You got it. Think about setting up dominoes. How you line them up, that'll totally affect how they fall. But it doesn't change the fact that you are the one who set them up in the first place.
Okay, I'm with you. But no time travel. Then what makes something a cause in this weird backwards scenario?
Philosophers, man, they've been going back and forth on this forever. One idea is all about counterfactuals. What ifs? Let's say a lake freezes over. So you could say, if it hadn't been so cold last night, the lake, it wouldn't be frozen.
Makes sense to me.
Hold on, though. Couldn't you also say, well, if that lake wasn't frozen solid this morning, then last night couldn't have been that frosty? Which one is the real cause, then? That's the thing with counterfactuals. Tricky, especially with backward causation.
Okay, so maybe counterfactuals aren't the answer. What else is there?
Some philosophers, they go for probability. Like, what if instead of directly causing something in the past, the future event, it just made that past thing more likely to happen? Loaded the dice, you could say.
Getting awfully complex here.
Right? Makes you think. And it gets even wilder when you wonder, can you even outsmart backward causation? If it's real, can you find a loophole?
Outsmart it.
Yeah.
How do you mean?
All right, so there's this thought experiment, right? It's called Black's bilking argument. And it uses Houdini, the magician. Picture this. Houdini's predicting a coin toss. He says heads, and boom, a minute later, someone flips heads. Backward causation would say that future flip somehow made Houdini say heads. Yeah.
All right, I think I'm following.
But what if, after Houdini says heads, we change it up? We say, no coin toss, we're pulling out a quarter. Or we rig it to land on tails. The point is, if we change what we're doing after the effect, which is Houdini's prediction, can we stop the coin toss? If we can, then was it really backward causation in the first place?
Interesting point. If you can dodge the cause after seeing the effect, does it even count as the cause anymore?
Exactly. And this leads us to the big question about backward causation free will. If the future can mess with the past, even a little, are we really making choices or are we just, puppets?
That's what I was thinking. Is our whole life just some script and we're playing our parts?
Yeah.
No real say in the matter?
Here's where it gets really interesting. Just because, say, an outcome might already be set, right, doesn't mean you don't have free will.
Mhm.
This is where philosophers talk about a determined future versus a determinate future.
So even if we know the ending to a movie, it doesn't take away from watching it all happen, right? Our choices still matter even if the ending's already been written.
Exactly. Our choices, they're the journey, right? Even if the destination's already there. What we do still matters, even if the future's got its own influence going on.
Okay, that actually makes me feel a bit better. But this is all, theoretical. How does any of this actually work in the real world? Physics and all that, that's where it gets really wild, right?
Oh, absolutely. And that's where this delayed choice quantum eraser experiment comes in. But we'll dive into that after a quick break.
All right, so we're back, and before the break, we were right on the edge of quantum physics, about to tackle this delayed choice quantum eraser thing.
Yeah, this experiment, it really messes with how we normally think about time, cause and effect.
Seriously, it's like we need helmets for this part of the dive.
Yeah.
So what is this delayed choice quantum eraser all about? Can you break it down for us?
Okay, imagine, right? The double slit experiment. Classic. You shine the light through these two tiny slits, and it makes this pattern, like waves interfering with each other. Now, here, we're using photons, those little light particles, and things get weird fast.
Right, I kind of remember that from, like, way back in school. But how does that connect to backward causation, though?
So, in the delayed choice quantum eraser, each photon, we split it into two entangled photons. It's key to the whole thing.
Hold on. Entangled. What does that even mean?
Think of it like, two coins flipping perfectly in sync, but they're like galaxies apart. That's entanglement, kind of. This freaky link where these two particles, no matter how far apart they are, they're connected. If you measure one and it's spinning one way, boom, you know instantly the other one's spinning the opposite way, like they made this a pact or something, defying distance. Super weird.
Okay, my brain's already bending a bit here. What happens to these entangled photons in the experiment, then?
Right. So one photon, we call it the signal photon, it goes straight to a detector. The other one, the idler, takes the scenic route, bouncing around through beam splitters, mirrors, the works. And here's the kicker. We can decide to measure the idler photon's path after the signal photon hits the detector.
Wait, so we're making a choice about a photon in the past, but its twin's already been measured in the future. Doesn't that, like, break the timeline?
You'd think so, right? That's the crazy thing. What's even wilder is the result. So if we erase the info about which path the idler took, bam, suddenly the signal photon shows this interference pattern, like it knew what we were going to do, even though we hadn't done it yet.
Whoa, hold up. You're saying our present choice, it's messing with how the signal photon acted in the past.
It's tempting to see it that way, yeah. But here's the thing. Most physicists, they'll tell you no actual retrocausality happening here.
So no backward causation, really.
Yeah.
But then how do they explain these results? It's like defying logic.
One way to think about it is that we only see that interference pattern after we've measured the idler photons and then use that data to like categorize the signal photons. It's not that we're changing the past itself, more like we're changing how we see it because of what we know in the future.
Hmm. Yeah, that's still super weird, though. And what about that whole block universe thing you were talking about before? Does that factor in here?
Definitely. See, if we ditch the idea of time as this flowing river, right, and instead we see it like a frozen block, where every moment, past, present, future, it's all there at once, then the future influencing the past, it's not such a crazy idea anymore. Like we're just looking at different parts of a big, unchanging sculpture, and our measurements are just showing us different angles of something that's already there.
So less about the future changing the past and more like both are just tangled up together in this block universe idea, our understanding of them at least.
Exactly. It definitely makes us question our usual ideas about time and cause and effect, but it doesn't automatically mean that the future is out there, like rewriting history or anything. There are other ways to see it, too. Take Eberhard's theorem. It basically says that you can't break causality using quantum stuff if the standard equations of quantum field theory are legit. It all comes down to how you understand the entangled state itself.
This whole thing, it's really making me rethink time, I gotta say.
That's the cool part about these quantum experiments, right? They push us past what we think we know. But even if it's not like literal backward causation where the future changes the past, this experiment is about as close as we've gotten to observing something that looks an awful lot like it.
It makes you wonder, what is reality even?
Right. And how much control do we really have over the choices we make, the things we do? Big questions.
Which brings us right back to free will, doesn't it? If this block universe is a thing, does that mean our lives are already, like, written out? We're just going through the motions?
Philosophers, physicists, they're all still wrestling with that one. But even if our choices are predetermined, which sounds super strange to say out loud, it doesn't mean that our experiences don't matter, that our lives don't have meaning.
So even if the path's already set, we still gotta walk it, feel every step.
Exactly. And those experiences, the choices we make along the way, that's what gives life meaning, purpose, regardless of whether that final destination was already decided or not. It's like reading a good book, you know?
Yeah.
Even if you know the ending, it's the journey that makes it a good read.
Man, this is a lot to take in.
It is, yeah. But that's the fun part, isn't it? Always more to learn, more to question. That's what keeps things interesting.
For sure. We've covered some seriously complex stuff today, and you've made it understandable, actually fun to think about.
Hey, thank you. I'm glad we could take this journey together, you know? For everyone listening, hopefully it sparks some new questions, makes you want to learn more.
Absolutely. And for anyone who wants to go even deeper down this rabbit hole, we've got you covered. Remember those sources we talked about earlier? The Stanford Encyclopedia of Philosophy entry on backward causation is a great start, and that Wikipedia article on the delayed choice quantum eraser will really blow your mind.
And hey, that's the great thing about knowledge, right? It's always expanding, always more to learn, more to question, more to wrap our heads around.
Couldn't agree more. So until next time, everyone, keep those minds open, keep that curiosity alive, and never stop exploring. The universe, time, who knows what we'll uncover next.